Hello, today I'm going to show you how to know your Pythagorean identities. Not necessarily memorize them, but come up with them every time you need them. So you may have already learned that these are your Pythagorean identities, but you're having a difficult time remembering them. Well, let me show you a quick, easy way to do these. First thing we need to know is how does sine squared plus cosine squared equal 1? If you can understand that, you can come up with the other two very quickly. Well, it goes back to our unit circle. If we look at our unit circle and just pick a point on the unit circle and draw a line to that, remember the radius on the unit circle is length 1. And then we have on that circle a point, we're going to label it x, y. Think of it as this is your origin and you're going over x amount and then you're going up y amount, and this is a right triangle. Well, based on Pythagorean theorem, we can say that this side squared plus this side squared equals this side right here squared. Or in other words, x squared plus y squared equals 1 squared. Let's write that down. Now, if you've watched my other videos on the unit circle, we know that the y value is the same thing as our sine value in the unit circle, and the x value is the same thing as our cosine value. So another way to write this is the cosine squared, because that's the same thing as our x value, plus the sine squared is equal to 1. So cosine squared plus sine squared equals 1. Hey, guess what? That is our first Pythagorean identity. If you can have that first Pythagorean identity memorized, sine squared plus cosine squared equals 1, you can come up with the other two Pythagorean identities. Let me show you how. The first thing I want you to do is write out that first one twice. So we're going to write out one up here at the top and one at the bottom, and we can come up with the other two identities. What I want you to do is take this one up top and divide each term by sine squared of x, and that will give you the second one. Let's try it out. Divide each term, and because we are dividing each term, this equation stays in balance. We're not changing the equation. And I get sine squared divided by sine squared. That gives me 1. And cosine squared over sine squared, remember that cosine over sine is cotangent, so cosine squared over sine squared is cotangent squared. And then 1 over sine squared, that is the same thing as cosecant squared. Notice that this one right here is the same as the third one on the list here. So we just came up with, by memorizing sine squared plus cosine squared equals 1, if you're in a quiz or a test, divide everything by sine squared, and you will get this one right here. Now to come up with the next one, instead of dividing by sine squared, we're going to divide by that other term, cosine squared. So divide each one by cosine squared. And then simplify those fractions. So when I divide this first one, I get sine squared over cosine squared, which is the same thing as tangent squared. And then cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared. Notice that that is the second one on the list here. Just the tan squared and 1 are switched around. But it's the exact same thing. So what I would do if I were you, if you're on a quiz, a test, whatever you're working on, you got to deal with this stuff. No sine squared plus cosine squared equals 1. You're going to see that a ton in calc anyway. You better go ahead and know it. And then divide each term by sine squared, divide each term by cosine squared, and before you know it, doing this enough times over, you'll get to know and recognize your Pythagorean identities as you do trig problems. I hope this helps. If you have any questions, let me know. If you're not in my class, please subscribe to the channel. I got a ton of math and physics videos that are coming out every week. So I always appreciate new people, especially when they're not in my class. I appreciate my students also, but I like helping people from around the world. Thanks for watching, and I hope you're having a great day.